it out right now for free. Finally, you have a way to simulate your rockets that gives you the true information that you need to be successful. And the best part is that you don't have to walk after your rocket after it comes back down to the ground. Experience the fun. Test your rockets right now at RockSim.com. Most rocketeers seem satisfied with just being told how high their rocket flew, and that's a shame. How did the rocket get to that point? That is what you should really be concerned about. The story of your rocket's not a peak altitude number. The real story is the trajectory path that your rocket takes during the flight. Does it go straight up or does it arc over? Does it spin as it ascends? What happens once the recovery system is deployed? Where does the rocket go? How far away does it land? Will it touch down in a location where you can easily recover it? These are the answers that you can get using the Launch Visualizer. It is an app on the RockSim.com website, and you can test it out right now for free. Finally, you have a way to simulate your rockets that gives you the true information that you need to be successful. And the best part is that you don't have to walk after your rocket after it comes back down to the ground. Experience, test your rockets right at RockSim.com. Most rocketeers seem satisfied with just being told how high their rocket flew, and that's a shame. How did the rocket get to that point? That is what you should really be concerned about. The story of your rocket's flight is just not a peak altitude number. The real story is the trajectory path that your rocket takes the flight. Does it go straight up or does it arc over? Does it spin as it ascends? What happens once the recovery system is deployed? Where does the rocket go? How far away does it land? Will it touch down in a location where you can easily recover it? These are the answers that you can get using the Launch Visualizer. It is an app on the RockSim.com website, and you can test it out right now for free. Finally, you have a way to simulate your rocket that gives you the true information that you need to be successful. And the best part is that you don't have to walk after your rocket after it comes back down to the ground. The fun. Test your route at RockSim.com. Most rocketeers seem satisfied with just being told how high their rocket flew, and that's a shame. How did the rocket get to that point? That is what you should really be concerned about. The story of your rocket's not a peak altitude number. The real story is the trajectory path that your rocket takes during the flight. Does it go straight up or does it arc over? Does it spin as it ascends? And we're live! Touchdown! I do that every week. I find it fun. Welcome to RockSim Live. I am Tim Van Milligan. I am your host. Here is where we talk about the RockSim software, RockSim Pro, and the Launch Visualizer, because it's all kind of like a little family of tools to design rockets. They're very close together, so if you have one, you'll be right at home here. So over here I've got a monitor, and I've got people checking in already, and I've got things dinging on me, so I gotta quit that. We have Low Budget Bob from Buckeye, Arizona, Alfred Indy from Michigan, Art Applewhite from Texas, David Pomeroy from Wichita, Kansas. I don't remember seeing that name before. Welcome, David. Rick DeFosses from snowy New Hampshire, and Carlos from Marietta, Georgia. Cool. If you are watching this on replay, we do these live at Friday at 2 p.m. Mountain Time, which is 4 p.m. Eastern Time Zone. Yeah, so you're welcome to show up live and ask your questions, because that's what we're here for, to answer questions. I'm going to need to switch to my screen here. Oops, wrong one. This one. And then bring up a web browser. So if you go to apogeerockets.com, which is our website, this is where you'll find RockSim. So you just kind of scroll down, and it says free RockSim training every week. That's what we're doing right now. That's our RockSim Live. And there's a little banner on here, and if you click on that banner, it will take you to our archives where we store these so that you can watch them later. And if there's a particular topic that you're interested about, this is where you can find them. Last week was episode number 103. Today is number 104. It's January 20th. Last week we talked about the quick draw rocket, which I brought back with me. Let me go back to here. There it is. That's the quick draw. We talked about that, and it's got a cluster motor mount that's removable. And I thought today, just like that, you can take that out. I thought today we would talk about how to put this removable engine mount in RockSim, so you can swap them out with different engine mounts. So that's what we talked about. We also talked about entering wind data into the Launch Visualizer, and we discovered a bug in the Launch Visualizer. And since last week, I got a message from the programmers that the bug has been fixed. So we'll maybe check that out to see if the programmers did actually fix that bug. That's the nice thing about the Launch Visualizer. Because it's in the cloud, we can make changes, and it just rolls out to everybody real quick. So the future of software is in the cloud, and it's for this very reason, so that when we make changes, we can get it out to everybody really quick. Okay, so no other questions there. I was looking for the questions, but no one has any yet. If you're on the website, if you go to the how-to and guides and click on that and come down here to software, click on that. This is where you'll find, your general information about RockSim. You can download a free trial. It's a 30-day free trial, so why not try it out? If you want to purchase it after your 30 days, this is where you would click. Kind of what is RockSim in general. In general, it's so you can design rockets and simulate them before you actually start building them. Some of the features in it, the most frequently asked questions, what you can do with RockSim, system requirements, and version history is right there. We have additional tutorials right here, in addition to our RockSim Live training tutorials here. And then we have some on RockSim Pro, which is a little bit different, particularly in the simulation of your rockets, because RockSim Pro is more versatile, so it gives you a lot more options for doing flight events, so things that happen after the rocket takes off. So that's in RockSim Pro. That's kind of what that is. So I wanted to talk about the quick draw today and the motor mounts. So I'm typing in on our website the word quick, and you can see down here it popped up that it found it in the search. You know, if I type it in quick draw, you can see that it brings up the menu and finds the object that we're looking for. That's my fast way. I love this feature for finding things on the Apogee website. So let me scroll here. Here's a picture of the quick draw. And this one has a 2-engine cluster in it. This is me holding it on the rocket range. This is where we flew it. This is actually a 3-engine cluster on that flight. One of the flames is obscured in the background. So that's what it would look like if you use a single engine in it. It comes with a single engine mount and a cluster of 3, but you can also purchase separately the 4 and the 2. So you can do a single 29, a dual 29, 3 cluster of 24 millimeter motors, or a 4 cluster of 24 millimeter motors, all into this same rocket kit. And what I thought we'd do today is to show you how to swap out those engine mounts, one of the methods. So if you're on the website, you go down here to this gray bar, and this is kind of like a menu bar. You just click on the RockSim file and it jumps down to the bottom of the page. I'm way down, like 2/3 of the way down is where the RockSim file is, and you can download it right there. And I've already got it on my computer since I've been playing with it. So that's RockSim Pro. I want to be in RockSim, so I got RockSim Pro in the background. So here's RockSim, and I'm going to open that file, but you can download it from our website if you don't have it, and you can play along as we go. So under RockSim Designs, Quick Draw, and you'll notice that in the file that you'll download, there's a RKT file with the file extension RKT. That's the RockSim file. It stands for rocket. And then there's also PNG files, which are images, and these are textures. So this is all the decals that go on the rocket. So when I open this up, and so I just drop it onto RockSim, it didn't work. Oh, because I'm not. Not in there we go. I clicked the wrong button, so you're not seeing me. Nobody caught it yet. Why is this beeping at me? Most rocketeers seem satisfied with just being told how high their rocket flew. And that's a shame. How did the rocket get to that point? That is what you should really be concerned about. Your rocket's flight is just not a peak altitude number. The real story is the trajectory path that your rocket takes during the flight. Does it go straight up, or does it arc over? Does it spin as it ascends? What happens once the recovery system is... That screen. Oh, I think I clicked on it. That's why. Let me move that over there. I keep clicking on the wrong button. Hello, Ernie Marsh from Erie, Pennsylvania, near Pittsburgh. Cool. And we also have Neil Morgan. And Neil Morgan has our first question. He asked, do you have a new catalog? And the answer to that one is we don't do a print catalog anymore because we have well over 3,000 products. And to print a catalog that thick for a small company like ours, we just can't afford it. So everything of ours is on our website at apogeerockets.com. And it's the fastest way to find things. I'll bring it up one more time. So I'm on the quick draw page, but if you scroll up and you're looking for something like a rocket kit, this is how we would recommend that you find, or if you're looking for a rocket kit, because that's what mostly people, when they're getting a catalog, they want to see the kits. They're not so much concerned about all the little bits and pieces like nuts and bolts and things like that. But if you go to the website, they're all there. So if you go to shop and you come down here to model rocket kits, click on that and you'll get this menu. And what I recommend is down here is a sortable list of rocket motors, or rocket kits, I'm sorry. You can browse through different skill levels and bulk packs, but if you go here, you get them all. And you get them all as one big list. And that's what's opening up here. And it's still loading. And they're I don't know what they're sorted by, because it's definitely not alphabetical. But if you want to sort them by alphabetical, you just click on the rocket name column and it will resort the list. If you click on it twice, and it goes in reverse order. So now I'm going from the A's all the way up to the Z's. And you got little pictures here that you can kind of see what they look like. And you can tell who manufactures it, what skill level. And again, if you want to sort by any of these categories, you just click on the column header and it will resort. So if you're looking for a particular diameter rocket, you can say, okay, click on this one right there, click on diameter. So then it sorts it by the skinniest to the biggest, and then you could just scroll down. And it's like, let's say I'm interested in a 4-inch rocket. So I just keep scrolling down. I'm looking in this column right here for a 4-inch, so I'm not there yet. It's going to be near the bottom. 2-inch, 3-inch. Okay, so now I'm in the 4-inch diameter section right here. So now I could start looking for something that strikes my fancy. If you want a really cool kit, I would get the Apogee Zephyr, and then you can click on that and it'll take you to the Zephyr page. This is a 4-inch diameter rocket. This is a really good rocket if you want to get your level 1 certification. You can click on the images here and it gives you bigger images so you can see what they look like. You can see that's a big 4-inch diameter kit. So, Ernie, we don't really have a, Neil, we don't have a catalog, but everything's on the website and you can look at it on your phone while you're in the bathroom, which a lot of people, they're paging through something or they're scrolling. That's the reading room, right? Anyway, back to this. So there's 2 ways to do this. One way is to create a design file for each of the different configurations. And personally, that's what I would do. But some people want to just minimize the number of things that are stored on their computer. So they want just one design file, and then they want to swap engine mounts between that. And so what's the fast way to do it that way? And so that way is with a feature in RockSim called sub-assemblies. So something like this motor mount right here is a sub-assembly, something that you can pull out of the rocket and put it into another rocket. So you can take it from one rocket design or put it into another one. And so that's the beauty of sub-assemblies. So I'll show you how to create a sub-assembly. So right now this rocket has a cluster of 3 engine mounts in the back. And if I go to the rocket design components tab right here, this lists a parts tree of all the components in the rocket. And if I click on the body tube, aft body tube right here, it will expand it. And you can see there's a lot more parts down here. So I have a cluster motor mount tube number 1, number 2, and number 3. I got a whole bunch of centering rings in the front and removable centering rings back here. We got a lot of stuff, and so we're going to add all this stuff to a sub-assembly. So what is a sub-assembly? So consider it like a collection of parts. So if you're in the parts tree right here, you see if I collapse this, this is a collection of parts. And so a sub-assembly is going to be another collection of parts. And then the nice thing about it is I can save it like I save a design, and I can take it and put it into a different rocket. So the process of doing sub-assemblies is first we're going to create the part holder, the container, like this sustainer right up here. We're going to create that first. Then we're going to add parts to it. And then once we get all the parts added to it, we're going to save that. And then we can go into a different design and load in that file, in that sub-assembly, into the rocket. So first you have to kind of specify where in the rocket you're going to put it. It can be anywhere. Because it's a sub-assembly, really it could be anywhere. But I'm going to put it down here in the bottom of the rocket because that's like where my mental imagery is of this sub-assembly. So I have to find a part that I can add it to, and you'll see over here on the right side there's a button at the very bottom right here called sub-assembly. And if you click on the wrong component, you can see that it's grayed out, that I can't add it. So I can only add it to certain items, like body tubes. Can I add it? I can add it to a nose cone. I can't add it into a coupler. I can add it into another tube, but not a coupler. So what I'm going to do is I'm going to add it to this tube right here. So that's the aft body tube. So I need to highlight it, then come over here to sub-assembly, and I'm going to click on that. And it's going to give me an alert, and it says, is the new sub-assembly to be owned by the selected body tube? And I'm going to say, yeah, the body tube owns it. Okay, so now it created it, and it's thinking about it. Okay, so then it brings up this screen right here. And this is where we're going to name our sub-assembly. So I'm going to call it, I'm going to start out with a single engine motor mount. So I'm going to do a 1 by 29 millimeter quick change motor mount. And I can give it a file name. It's not, I can load parts from a file or save parts to a file. So right now I'm just going to leave that alone. And it's asking me for a location. And if I click on 2D, it's going to be somewhere in here. Right now you can't tell where it is, but we'll see it later. And I can change the location later. I think right now it's right at the front of the tube, which is right here in the middle of this tube coupler. Okay, we got another comment here, and we'll get to those in a second. I want to get into sub-assemblies. I want to keep on the sub-assemblies for a little bit here. Okay, so I'm going to click OK, and now you see that there's a new part right here. It's called 1 by 29 millimeter quick change motor mount, and you can see it looks like a file folder. Because it's a collection of parts. So we're going to stuff other parts into there. So now what parts am I going to stuff in there? So if I look at this motor mount, it's got a whole bunch of rings and a whole bunch of tubes. So I'm going to just start with the rings, and actually Forward removable motor mount, aft removable motor mount. Okay, so actually the parts are already in here. So I'm gonna take these parts and I'm going to add them to this. So I'm going to do a cut of this part. When you do a cut, it actually saves it to memory, temporary memory, and then you can paste it. So I'm going to do a cut. And it's going to say, do you really want to do this? I'm going to say yes. So I took that out, and now I'm going to go into my, highlight the folder here, and I'm going to say paste. And to get this little menu, what I did was I right-clicked with my mouse, and I hit paste. And you can see now it put that ring that used to be here up into here. So I'm going to do that the same thing with this one. Cut, say yes, come up here and paste. And it pasted it in. I'm going to do the same thing with this one. Cut, yes, and paste. Okay, so it pasted it in there. The fins, I'm not going to put in the sub-assembly, but I am going to put in not these cluster tubes, because I'm going to go from a 3-engine cluster to a single 29 millimeter, so I don't want that. But when I'm looking at this ring, this motor mount tube, so right here there was 3 rings at the front. They're just stacked up together, and then there's 1 ring in the back, so I want that ring. It says aft removable mount centering ring, so there it is right there, so I want that one. So I'm going to cut, say yes, come back up here to the folder, highlight it, and paste, and it pasted it back in. And I think that's all that I want. Now I need to, I'm going to delete these 3 cluster tubes right here because I don't need them. So I'm going to do a file, delete. I can do a cut or a delete, either one. Delete that, yes. Delete that one, yes. And then delete the 3rd one, delete, yes. So if I look at this from the back, it does not like my computer. Go look at it in 2D. Okay, so as you can see, it's hollow right now. There's no motor mount back there. So what I'm going to do is now I'm going to create a motor mount tube. So I'm going to, again, I hit the start in the quick change motor mount folder, and I'm going to do an inside tube as my new part. And now I need a 29 millimeter motor mount tube. So I don't want that one. I want this one right here. Because I know from Apogee that one is a thin walled tube. This one right here is a thin walled tube. So the outside diameter is 1.18. This one down here is 1.21, so it's a little bit thicker because that's what we used on this particular rocket kit. Is we used a thick mount or thick wall tube. So I'm going to say OK to that, and you can see that it put that tube way up there. So that tells me. So here's my tube in blue. And here's my rings right here. And when these centering rings right here are positioned back from the tube right here, and that's probably going to cause a problem. It's not so much a problem, it's just going to cause extra work in the future. So what I really should have done was move those rings all the way up to the front here at the start of the sub-assembly, because right now they're back here. I'll just go ahead and leave them back here, and then I'll show you where the extra work is going to come. So on this motor mount tube, first I want to move the location. I'm going to slide it back, and I want to slide it back so it's at the front of those rings right there. I think it's like right there. And then the length, and I think the length is 3.75 inches, because I think the 29s is the same as the 24s, and in the 24s we use 3.75 inches long on that tube. So 3.75 inches, and so there's that tube. Let me zoom in so you can see that tube. That's the correct length. That's good. And this is a motor mount tube, and you can see it already selected 29 millimeters. I kind of knew that. I can change the color here if I want. I think I'll change the 2D color at least. Make it purple. And my 3D color is white. I'll just leave that. And click OK. So now we're looking at the back end. Let's look at it from the side view. So there is that motor mount tube. Also on the motor mount tube is an engine retainer. On this one we used a threaded rod retainer. So let me show you a picture of what that looks like. Let's go to quick change. Okay, so here are the motor mounts. Let me go to this one. Actually, I want to go, see, that's a 3x24. I need a 1x29. Here's the 1x29. Click OK. So there that is. And if you click on it, what you see here is this right here. That's a threaded rod, and we bond it to the tube with epoxy. And that holds your rocket motor into the rocket. If I look at it from the rear view, you can see that that there's the rod, and then it's got a little nut and a washer that captures the back end of the motor and prevents it from sliding out. This works really good, and they're cheap. They're cheaper than a screw-on retainer, which is why we used it. We're just trying to keep the cost down. But that threaded rod does have some mass, so let me find out what that mass is. So I'm going to go threaded rod. If I scroll down, here it is, threaded rod retainer system, and it weighs 12 grams. That's what I was looking for, is the 12 grams, because I'm going to add that to the motor mount tube, and I'm going to add it as a mass object. So I'm going to come up here again because it's inside of my quick change motor mount, and I'm going to go to a mass object, and I'm going to ignore the database, and the mass object right now is right there. We're going to call it 12 grams, and we're going to move it. I'm sliding it back. I'm going to slide it to about right there where it would probably balance in the rocket. And let me call this the threaded rod retainer. And I'll click OK. So there it is. So at this point, my quick change motor mount is ready to save. So I'm going to come back up here to the quick change motor mount collection of parts, and I'm going to double click on it, and now we're going to save it. And so now I need to give it a file name, and I'm going to call it the same as the actual name so I can find it. And then you're going to save parts to the file. So I'm going to do save, and it looks into the last folder that I was looking at. So I'm going to paste in that name again. It should have pasted in there. Oh, it doesn't want to let me paste it. 1x29 millimeter quick change motor mount sub-assembly, and I'll hit save. Holy cow, look at that. Oh, okay, what it was looking for here was this is the file path. So this is the entire file path. So if I go, okay, so on my computer, it's in the users, Tim Van Milligan documents. Inside of there is a documents, RockSim designs, quick draw, and then the file name, 1 by 29 millimeter quick change motor mount system sub-assembly, and then it adds a file extension RSA, which stands for RockSim assembly or RockSim sub-assembly. So it's been saved, and I click OK. At this point, we can run some simulations. Let me do a. I'm going to just do a save as, because I want to just hold my thing here. So I'm going to call this quick draw 1 by 29 millimeter. So I know what it is, so I don't override the one that I downloaded from the website. Okay. So we can run a simulation here. So now when I go to load motors, I should only see one motor mount tube in here. And I'm going to choose an engine, and I'll just randomly select something. Aerotech. Let me sort by engine code. I want to get an F motor, so let's do an F25. Maybe a 6-second delay. Click OK. Engine overhang. I think with this engine mount system, it's going to overhang 0.25 inches, a quarter inch, because that's the thickness of the thrust ring that's on the back of the rocket engine. Now just seeing what we got here for flight events. Deploying at maximum ejection delay. We're going straight up. And let's launch it and see what it looks like. Just to confirm everything is working. So here's the rocket on the launch pad. These black lines right here are called the weathercocking cone. This kind of tells us if the rocket's going in the direction we want. We want the apogee point to be somewhere up in here. And let's see, when we launch it, and the rocket goes pretty straight. That's pretty good. You can see this is the smoke, and it's drifting a little bit. So there's a little bit of wind in this simulation, but not much. And the apogee point was within the cone. So that's a good flight, and it deployed the parachute pretty close to apogee, so I like also that. I picked my delay pretty good. And then it's coming down, and it's going to land about 374 feet downrange with a total flight time of just about 70 seconds. So that simulation worked just fine. Okay, so now let's create let's go and create a new design and bring this sub-assembly into this new design. So I'm going to start out by creating a new design, and I'm just going to do a very simple design. So if you're brand new to RockSim, this is how you create a design. Come up here to new design file, click on that. It's going to ask me, do I want to save this? And I'll say yes, because I just ran a simulation. So now we're going to, when we design a rocket, we work along here on these tabs. So I'll start with the first tab, and I'll just call it BT-80 Simple Rocket. And I'm just going to go to the next tab. I'm just going to leave everything else alone. Go to the next tab and start designing. So now we need to add parts to this. I'm going to add a nose cone as the first item. We kind of work from the top of the rocket coming down. So I'm going to work with an Apogee, and I want a PNC 66, which is a BT-80. That's the hardest part of designing a rocket, is knowing the parts names. I have an advantage because I designed the parts and I know their names, but BT-80 is a kind of a standard size tube, and it's 2.64 inches in diameter. And if you convert that into millimeters, it's 66 millimeters. And so that's where this nose cone came in. You can see the diameter here at 2.6 inches. I like the nose cone, so I'm just going to say OK. Now I'm going to put in a body tube next to that. And again, I need a 66 millimeter or BT-80. So here's a 66 millimeter. I'm going to select that, and it threw that tube in there. It's going to be a little bit short, so I'm just going to lengthen it a little bit just by grabbing the slider. So I'm at 24.75 and I like it, so I'm going to click OK. Let's put some fins on there real quick. So I have 4 choices of fins. I have trapezoid and ellipticals, which are under the fins button. Custom fins are fins that have a oddball shape. So if I look at this fin right here, it looks like a trapezoid, but you can see it's got a nice curve right there and a nice curve at the back end down here. So that's not a trapezoid. So I can't use fins. I'd have to use custom fins if I wanted to do something like that. But for now, I'm just going to use regular fins. And then you also could put a ringtail on it, which is a ring around the outside diameter of the rocket. Those are really stable. Or you could put tube fins, which is a collection of smaller tubes glued directly to the inside core tube. I'm just going to do a regular fin, and this will be a simple trapezoid fin. Again, when you create a new part, it always looks in the database, so I'm going to ignore that. And it throws a generic fin on there. And if you like the shape of that, you can leave it alone, or you can start, moving these slider bars around. If I change the sweep angle, you can see it sweeps it back. And I can change the semi-span and make it skinnier, and it automatically readjusts down here. It tells me that this is a birch plywood. I think I would probably like basswood, which is a little bit lighter weight, but not quite as strong as plywood. And if you like that, you click OK. So now we have a generic rocket, and now we're going to add that motor mount into it. So here's where I'm going to add in a sub-assembly. So this is a new rocket design. I'm going to come over here to sub-assembly. So I'm going to click on that, and it says, is this new sub-assembly to be owned by the selected body tube? And I'm going to say yes. And now I'm going to load parts from a file. So before we saved, now we're going to load it in. So this is where we're loading it in. And again, it remembers that I was in the quick draw folder before, and you can see that it's looking specifically for files that end in .rsa, which is RockSim subassembly. So that's the one that I want. I'm going to click open, and you can see that it loaded it in there, except for where's my motor tube? Let's click OK. There's the motor tube. Okay. Now, so before I said that there was going to be some extra work involved, well, this is where the extra work is involved, because that motor tube and this mass object, which is right there, when we created the subassembly, they were referenced from the front of the tube. And I think the tube on the quick draw rocket, this aft tube, and right here is the dividing point, is 18 inches. And so when we changed the location, when we created the subassembly, we were referencing from a tube that's going to be 18 inches long. Now on this tube, it's longer, because I remember I made it 24.75 inches long. So now this has moved. And so again, I said, now we gotta tweak things. So this is where the extra work comes in. If I would have designed my subassembly correctly the first time, it would have worked. And if we have time, I'll design it correctly. But I can adjust it right here by going into the list of parts and finding that motor tube. So here's that motor tube right there. I'm going to edit that tube, and let me change the name of it. So I'm going to call it a 29 millimeter motor mount tube, and I'm going to change the location. I'm going to grab the location slider, and you'll watch it slide back, and it's sliding back to about right there where I want it, and I'm going to leave it right here. I could change this to the base of the owning part, and that is actually probably a pretty good thing to do, because then if I change the length of this tube right here, that should follow it. And I have to do the same thing for the threaded rod retainer. Again, just slide it back right here. I'm going to change it from the base of the owning part, so that it's referenced now 1.125 inches from the back of the tube instead of 20 something inches from the front. So then I'm going to click OK. So now if I open this sub-assembly right here and I change the location, you can see that everything's moving, which is good. That's what we want. Additionally, if I cancel out of that, save my changes, no, I can go to the body tube, and if I change the length of the body tube, this sub-assembly should move with it. So if I make this tube a lot shorter, you see everything moved except for the fins, because the fins were not referenced from the back end, they were referenced from the front end. So I should have thought of that, right? I'll just move it back here and click OK. Let me go to those fins and show you where you would change that. So again, if I was creating those fins, edit the fins by double-clicking, and then come down here to location, and you see the drop-down menu. Right now it's from the front of the owning part, and the owning part is this tube. And I'm going to say make it from the base of the owning part, and then click OK. So now if I change the length of the body tube, everything is going to move with it. And that's called designing smart. And click OK. Let me run a flight simulation here. So I got no flight simulations run so far. I don't have a parachute in here, so this rocket is going to crash, but we'll run it anyway. So it sees the motor mount. I'm going to say choose an engine, and I'll do an Aerotech F25 again. Make it a 9-second delay, although it doesn't have a parachute, so it's not going to do anything different. It's asking me to save my design, so it's asking me to save it. I'm not going to put it in that folder. I'll just leave it in there. We called this the BT-80 simple rocket. Hit save. Now it runs the simulation, and we can see the rocket right here. And this one should go up and come pretty much straight down because it doesn't have a parachute in it. Okay. Without a parachute, it's just going to come screaming down. And I'll stop it right there and drag it here. This time it only was 25 seconds in the air versus about 70 seconds previously. So again, that simulation worked. Let me go back to our original design. Let me save this one. See this right here? That means crashed rocket. I'll save that one. And I'm going to do File, Open, Recent, and we're going to look at the Quick Draw 1x29. And I want to correct that sub-assembly here, because this is our original sub-assembly. And what I want to change is those locations. So here's the body tube. Change it from the base like we did before, and we're going to call it the 1x29mm motor mount. And click OK. And then the threaded rod retainer, let's do that one as well. From the base of the owning part, click OK. And now I'm going to go back to my sub-assembly, and I'm going to save it again. And I'm going to leave everything the same. It's asking me to give it a new name, but I just right clicked or just clicked on it and it brought that up there. And so I should get an error message when I hit the save button that I'm overwriting this file, but that's okay. So I'm going to hit save. And there's the error message, and I'm going to replace it. So now I just replace that subassembly. So the next time that I open it up, I can just drop it in. Okay, so now I'm going to click OK. So now we got the single 29. My next one I want to do is a dual 29. So I'm going to have two rocket motors side by side, and they're both going to be 29. And it's really easy to do this in RockSim. Because I already got the single 29 right here. So I'm going to highlight this motor mount tube right here. And now I could duplicate it. I can duplicate it two ways. I could do it like I did before, where I cut it and then added it back, or you know, like a copy paste. Or I could come over to this button right here called cluster. And this is what I recommend that you do. Go to cluster, click on that, and it's going to launch what's called the cluster wizard. And so now we're designing a cluster engine mount, and it's going to walk us through the process. First, it's going to say select the cluster pattern. We can change the rotation of the tubes in the motor mount. We can specify naming convention for the tubes. And then finally, we'll finish by creating the new components. So click continue down here. And I have a choice of any of these patterns. I can do a 2-engine cluster, a 4-engine cluster, which you can see is not going to fit. You know, 6-engine cluster, 3 is not going to fit. The only one that fits is 2. So that's what I'm going to start with. And I'm going to say continue right here. And you can see I can zoom in. And these tubes don't quite touch the outside, but they're touching here on the inside. And I am going to, I like that pattern, so I'm going to click continue. And this is the rotation angle, so I could rotate it around any angle that I want. For our design, it doesn't really matter, because as you stick them in, they're going to rotate anyway. On some rocket designs, that does matter, but for ours, it doesn't. That gives you the final look. I'm going to go back to this one right here. For some reason, it doesn't want to allow me to change the minimum radius. What I wanted to do was to split these tubes just a little bit, because you know on the back end of a rocket motor it has those thrust rings, and if you don't split the tubes apart just a little bit, those thrust rings, since they hang over the outside of the tube, of the motor mount tube, they'll interfere with each other. So one motor will go in and the other one's not going to go in because it's being blocked by the thrust ring of this one. So to fix that, I have to go back. So I can't choose that one there. I have to choose this button right here, a 2-engine, or this one here gives you an unlimited number of motors and you have more control. And so, see, now I can change my cluster radius. I can grab this and calculate the maximum radius. See the maximum radius. You see right here, it looks like it's interfering, but this inner circle right here, that's one of my centering rings, or the tube coupler that's in the rocket. So that's what it's seeing here. My actual tube is the first, well, there. That's the inside diameter of the tube. So it automatically calculated that for me, and I want to bump that down just a little bit. Let's make it 0.6. So now it's 6 is not there. 0.65. I'll make it 0.62. Okay, so that looks good. I got a little bit of room there for my centering ring, and there's a little bit of room between the tubes so that I can slide in the two motors. And I'll hit continue, And again, this is, do I want to change the rotation angle? It doesn't really matter. I'll make it 90 degrees so it's side by side, and continue. And if you like what it looks like, hit done. And now it should have created, oh, there it is right there. Cluster motor mount tube number 2 and cluster motor mount tube number 1. They're just not together right there. There's a threaded rod in between them. And if I look at it from the rear of the rocket, you can see there's two engine mounts in there, which is really good because that's what we wanted. And if I look at my centering rings, so my aft removable centering ring, if I edit that, you'll notice that this screen has changed. Well, so we did a copy and paste before, but when you have a cluster, it will show you that there's 2 circles in there. And that's important because if we wanted to actually build this ourselves, we need to create a centering ring pattern, print out the pattern, and we want those holes in the right spot. And so RockSim is automatically calculating it. And I could say export the template here, and it's going to export out an SVG of that centering ring. And this is, I'm going to call it a centering ring so I know what it is. Centering ring. Click. Now this is a 2x29, not a 1x29. Hit save. And it exported it. And where did it put it? And it put it into the quick draw folder. So if I wanted to look at that, I would have to open up a browser window and go to that folder where it's stored, and it stored it here, and it was inside the quick draw folder. Here's the quick draw folder, and here's the centering ring, and I can open it, and it's in SVG, which is scalable vector graphic, and that's a drawing graphic. So you would need something like Inkscape to open it on Windows, or Adobe Illustrator. And I have Adobe Illustrator down here, so I'll just drag it into Adobe Illustrator just quickly here and show you what that looks like. If it wants to load that. Yeah, it wasn't started. Take a sip of water real quick. Okay, so here is that centering ring, and let me change the color from gray to no color. Come on, what's it? I gotta grab the right thing. Okay, so let me do select all. Now let me make the stroke thicker here so that you can actually see it. Here's the stroke. I get 2 point. Okay, so that's what our centering is going to look like. So we can print this out and actually cut it out. That's why it's important when you design the rocket to click on that cluster button, because that way the centering rings will automatically adjust. Okay, so now I'm going to click OK here. So we have our centering rings. Let me go back to a side view. And now we need to save this again. So this time it's a 2x29 millimeter quick change motor mount. And when I save it, I want to have it as a 2x29 millimeter. And I'm going to hit save. And I'm going to select that because then I don't have to type everything all over again. 2x29 millimeter quick change motor mount sub-assembly.rsa. Hit save, and now it has saved it. Click OK. So now we can use it in our other design. So if I open my previous design, the BT-80 simple rocket, click open there. Do I want to save the changes to this one? And I'm going to say let me cancel. Actually, I do want to save this, so I'm going to do File, Save As. I don't want to do Save because then it would override this 1 by 29. So now I'm going to do this one as a 2 by 29. Hit Save. But now if I go to my simple BT-80 rocket right here, open that, and we're going to delete this subassembly and we're going to add in the new one. So again, I'm going to delete it and say yes, and it deleted everything. I'm going to select the tube, click on the subassembly button, and it's asking me, is this tube owning it? I'm going to say yes. And now I'm going to load those parts, and it's going to be the 2 by 29. See, now here's the 1 by 29. Here's the 2 by 29. Click open. And my motor tube's in the wrong spot, but my mass object is in the right spot. So how did I not do that? Click OK. But I can adjust that. I'll probably have to do it twice. See, it says from the front. It should have been from the base. That was one tube. Here's the other tube. From the base, it's going to be 0. Okay, so now we have, if we look at it from the back end, there it is. And then we can run flight simulations by going up here to prepare for launch. And we have to choose the motors. I'll just choose the F-22J. Let's do a 7-second delay. Click OK. It loaded in one of them, and we need to load it into the other one. To do that really quick, you just hit Load All, and it just duplicates that motor in all the tubes that have that same diameter. And then we'll do the flight profile. See where this one goes. This one also crashed because it doesn't have a parachute. I'm going to just use the slider bar and see how high it goes. You know, it goes 3,200 feet. And it comes screaming down to the ground. Well, it actually didn't. This one came down sideways. You see that? It came down sideways because we have more weight in the back of the rocket. So that shifted the CG, which is very interesting. That's cool. RockSim saw that. I didn't even think about it. So our first one with the F-25, a single motor, went 2,200 feet. With two F-22s, it went 3,309 feet. So, and if I wanted to do that, I could do that for 3 engines. I could do it for 4 engines, and then I'd have sub-assemblies that I could swap back and forth. You know, the sub-assembly doesn't have to stay in the rocket. It can move from one rocket to another. So I have 2 ways of opening these designs. One, I could save the design as a whole file, which I showed you. Let me open that up. So here's the one, quick draw, where is it? Here it is, the 1 by 29. Here's the 2 by 29. The original design is this one right here. That's a 3 by 24, although it doesn't have a sub-assembly in it. It's everything's built into there. And then finally, here are sub-assemblies that we can move around from one rocket to another. So that is how you do sub-assemblies in RockSim. And I know I had more questions here, so we're getting low on time, so let me see what we got. Johan says the quality of the sound is good today. Good. Okay, Sturk03, he says, I started with the sustainer body first and then realized I did not start with a nose cone. When I went back to add a nose cone, it was grayed out and I could not select the nose cone. How do I get one? Okay, so what he did, let's start a new design. I'm not going to save it this time. So he started the new design. So he went to the Rocket Design Components tab, and he started, instead of choosing a nose cone, he started with the body tube. And I'll choose This is a BT60, so I'll click OK. So here's my tube, and click OK. So now on my parts tree, I have a body tube, but I don't have a nose cone. And what he says is when he comes over here, he's right. It's grayed out. You can't click on it. How do you add a nose cone to this rocket? Well, it's pretty simple. It's just you just have to go up one level. So here's a body tube that's selected. We'll select the sustainer instead. So now when I select the sustainer, now the nose cone is activated. And I just click on that, and then I can select, you know, a BT60 body tube. Where are you? Here's one. Fits a BT60. Click OK, and you can see now I have a nose cone in the parts tree. So that's pretty simple. It's just you just have to go up one level. And then he asks, second question, can I open an open rocket file in RockSim? And the answer is I don't know. I don't know anything about Open Rocket. All I know is the file extension for RockSim is .rkt. I have heard a rumor that in Open Rocket you can save your design as an RKT file, and that you might be able to open in RockSim. And I say might because does Open Rocket actually save it in the RockSim format? I don't know. I have never played with that, and I have no desire to play with that because that's, you know, that's not our software. You know, I'm working on RockSim. I'm trying to make RockSim a lot better. There's so many more things you can do in RockSim, from what I understand. I have no desire to go back. Johan says, oh, almost forgot. Any news on the ENG and RAS format manufacturing codes? Okay, so Johan wrote me an email, and he said that he was creating his own engine files, and he's having a problem having them show up in RockSim. And so, Johan, the question is, did you create the engine files by hand or another program, or there's a special little program that comes with RockSim called Engine Edit? It's in the folder where your RockSim application is stored. So on the Mac, my RockSim is in the RockSim folder. Here's my RockSim folder, and you'll see the RockSim. This is the executable for RockSim, which is what I'm running right now. And then there's another program called Engine Edit. And this is what you use to create engine files. So let's create a new engine real quick. So I'm going to add a new engine. This is how you do this. And you have to specify the burn time. And I'll specify it as 2 seconds and a peak thrust of 20 newtons. Click OK. And you can see it created a graph right here. So this is seconds. So my burn time is right here at 2 seconds. And then I can come over here, and why is it telling me pounds of force? Everything should be in newtons. It's interesting. That should have changed. Anyway, I should be able to just click on here. There we go. And that will create points that I can move around and create a thrust curve. And this thrust curve right here is it's just a little bit bigger than a D motor. A D motor has a total of 20 newton seconds, and we're at 24. Again, you just have to know that because I've been in rocketry a while. I'm just trying to drag this point down. 22. I want to make a D engine. 21. I got too much thrust. There we go. Now we're under 20. So now this is a D motor. Manufacturer unknown. I think, I don't know what he was calling his, TSI or something. So that's the manufacturer. I just made that up. I have no idea what that is. Okay. Engine code. I know because I've made engines that anything greater than 10 and less than 20 is a D motor. So my engine code is going to start out with a D, and then, you know, usually there's the average thrust after that. And here it calculated it for me at 9.6. So this is going to be a D. I'll round that 9.6 up to a 10. So it's a D10. And the engine type, I'll say single use. And then I can give it ejection delays. So I'll give it a 0, like it's a booster motor. I'll give it a 5, and then a 7, and maybe a 9. And I'll also give it a plugged, a P for plugged. That means that there's clay on the front end, that there's no ejection charge. And I'm going to call the diameter 24 millimeters. I'll give it a length of 75 millimeters. Then you have to give it a mass, and I don't know what a D engine weighs, so I'm going to cheat and go to the Apogee website. I'll type in a D12 for Estes, and I'm just looking for the weight. Total mass of 41 grams and a propellant mass of 21 grams. So that's what I'm going to use, 41 and 21. So initial mass 41 grams. Propellant mass 21 grams. Okay, so I have my engine. I'm going to say Tim's awesome motor. And then I need to save it. So I'm going to do file save. And it should ask me where I want to save it. And I'm going to save it on my desktop. And I'm going to call it the D21. And you can save it as the RAS format, .eng, or a RockSim format. It doesn't matter. The RockSim format holds additional information that the ENG doesn't. But you can use an ENG if you want. And I'm going to hit save. And it's just giving me a little alert that says that it's not going to save all the information that the RockSim format does. Okay, so now we've created a motor. And now I'm going to go, I need to open a rocket that has a 24 millimeter motor mount. So let me, I'm going to use that quick draw rocket. Save that one. Nope. It's drawing that. That's why it's taking long. Let me go to a side view. And then it'll be a little bit faster. Now I know that these motors right here are 24 millimeter. So if I go to prepare for launch, oh, before I do that, cancel, I got to load that motor into RockSim. So this is how you load a motor into RockSim. You go to File, and then you go to Import, and you're going to import engine files. You can import database files or engine files. We're going to choose engine files. And then we have to find our engine file. And this is why I put it on my desktop, because I know I put it on my desktop. So I'll go to the desktop. And there's the D21, and you can see it's highlighted, and I can select it and click open. And so now it tells me it copied that motor into my database. Okay, so it's in the database, and now I need to move it into my active database. So you can have a database with all kinds of engine files, maybe a whole bunch you never use. And so that's where it is right now. It's in the whole bunch of engine files on your computer somewhere. So now we have to tell RockSim, okay, move it into my folder where I'm actively using it. So you highlight it and then you say add. And so now it added that D21 engine right here. Click OK. So now we're in the rocket design. We're going to go to load engines. I want to choose an engine. And what do we call it? A D10 from TSI. There it is. Length of 75 inches. Hopefully that's in millimeters. Burn time of 2. Total impulse of 19. Average thrust, okay. Yep, that's a bad thing. Click OK. See, when it thinks it's 75 inches long. It should have been 75 millimeters long. Let me go back to engine edit. Oh, see, I said 75 inches. So that was my fault. If I would have made the engine file right, it would have been correct. But you get the point. I've loaded that engine in there, and I could load it into the other clusters as well. Again, highlight it and say load all, and it loaded it into all 3 of the engine tubes. And I can hit launch, and it launched it. It used a 0-second delay. It only went 382 feet. So something went wrong. I wonder what happened. Let's look at it in the 2D flight profile. Did it go unstable? No. Oh, since we used a 0-second delay, it opened the parachutes on the way up, right at engine burnout. So there's nothing wrong. It's just I set up the simulation wrong. I used 0-second delays instead of actual delays. So if I went over here, I went to my drop-down list. You can see I have custom plugged 057 or 9. I can load all. Now they're all 9 seconds, and if I hit flight profile this time, it's going to go a lot higher, and I saw that right here, 1055 feet, so a lot higher. So actually it's a good launch this time. So now that motor that's in my database, I don't want it in my database, so I'm going to go back up here to File. I'm going to go to Reload Engine Data, and Reload Engine Data brings up that screen that we saw before. So I'm going to take that D21 engine and I'm going to remove it, click OK, so that the next time, so if I try to go to load an engine this time, it's not going to find that D21 or that D10. See, it's not in there. So hopefully, Johan, that answers your question. I know that went really quick, but we were running low on time. Johan said, he says, I bet Michelle is behind the scenes so Tim won't screw up today. I screwed up, but Michelle is not behind the scenes. Michelle will be here next week because I'm going to not be here, so she will take my place. Carlos says you should use better names for mass objects. Remember when I created my mass objects? That was in my, I'm not in the sub-assembly rocket. You know, like this mass right here. What the heck is that mass? I have no idea. This is what he means by you should, use better names. Oh, I can see that mass right there is actually going to be a shock cord. So I can change that name so I can tell what that mass object is. Alfred Indy says Tim should wear his white uniform with a cowboy hat on the quick draw video. I used to have a cowboy hat and I don't know what happened to it. We had Narum, I think it was Narum 30 something here in Colorado, and it was in Penrose by Estes, and it was on a piece of land that Vern Estes owned, and we all wore cowboy hats as part of the range crew. It was a lot of fun. There's a whole bunch of comments. Rick DeFossa says, can sub-assemblies be saved into the parts database? Yes, you could, but there's no sub-assembly database like there is like nose cone databases. So each sub-assembly is saved like a design. So putting it into where the parts databases are stored is just going to make it hard to find, because if you know anything about RockSim, those parts databases are kind of hidden. So I wouldn't put them there. Put it where you save your designs. Maybe, in your design folder, there's manufacturers like Apogee, Estes, Aerotech, Quest. You could maybe make a new folder called sub-assemblies so that you know where they're located. We answered Johan's question about rocket motor names, and if he's still having problems, I'm not sure what's going on. Stirk3 says, yeah, I'm still a rookie, but it is interesting but handy to see the stability in adding or removing a weight, how it affects things. Easier than the cardboard cutout method. Oh, my RockSim quit on me while I wasn't looking. I don't know what happened. It died. But we're out of time anyway. We're way over time here. So I'm still looking at my monitor over here. Johan says, absolutely, he's replying to Stirk03. He says, absolutely, you can build models that are technically sound and appealing to the eye by fiddling around, also increasing safety and success with launch activities. The launch visualizer is totally awesome. We did not get to the launch visualizer today. We just blew through this episode, you know. We're 15 minutes overtime because we try to keep them an hour long. But I appreciate you being here. Like I said, we will be back next week, which is, I think we're in February 2 maybe? Bringing up a calendar here while I'm looking. No, February 3. So we will be back February 3 at 2 p.m. Mountain Time or 4 p.m. Eastern Time Zone. But it's not going to be me, it'll be Michelle. So save up your questions, send them in. Actually, send them in. Bring up your questions. And to send them in, go to the Apogee website, which you can't see here. Go to the Apogee website. Over here where it says talk to a real person, there's a contact form. So click on contact form and you can send an email to RockSim General Questions and Support and say, this is a RockSim Live question for Michelle. And then Michelle, this is Michelle. She will answer it next week for you. She really appreciates when people, because she likes to prepare. She's one of these preparing people. That's why she works so well here at Apogee, because I just give her things and she can prepare for it ahead of time. And then she's confident and she'll research everything, so she'll give you the right answer. So you can ask during the live event, but if you can give her some heads up, she really appreciates that. So again, thank you for coming. We will be back next week. So we're going to quit now. So in 5, 4, 3, 2, 1, go out and launch something. That was a great